Hello, I'm Pier Francesco Valerio, Structures Manager in Highways England, and today we are going to speak about the changes to the DMRB document management and assessment of bridges with half joints and deck hinges, the background to the new DMRB documents CS466 and CS467. The DMRB, the Design Manual for Roads and Bridges, has been updated as it contained aging documents of varying quality that did not reflect the needs of the users well. The updated DMRB will be consistent in style and format and intuitive to use. With clearly defined requirements in a reduced number of documents, advice is given more concisely and directly linked to requirements. It reflects industry best practice and encourages innovation and complies with relevant EU and UK legislation. The standards in a new DMRB do comply and are aligned with our new asset management policy and strategy. Highways England has recently developed and adopted an asset management policy and strategy, which includes all the work that is undertaken to support the business through concept, design, construction, maintenance, and end of life for all of our assets, including structures. Associated with this strategy is a plan to transform and continuously improve. It will support better planning and secure longer-term investment in our aging assets. The key themes in the strategy are customer service, so supporting users of our network, strategic planning and service delivery, ensuring optimal intervention, so maintaining safety and fitness for service, better use of asset knowledge to understand risks and support planning, adapting our whole life approach, then support for people with tools and training. Having robust and consistent standards and providing guidance is a key component of the asset management approach and underpinned the need for the complete review of the DMRB. The new DMRB has now been published and is easier to read and understand. Our new documents clearly state requirements you see shall or must. The new clause numbering is based around the requirements, with the top level being the requirement and the second level being advice. Supporting advice uses should or may verb forms, and notes use can. Today we discuss the update to the standards for management of bridges with half joint and deck hinges. In the 60s and 70s, there were a lot of bridges constructed in the UK, and to standardize and simplify design and construction, many of those bridges were designed to include half joints or deck hinges. These are critical components with low robustness, as they are vulnerable to deterioration and they are difficult to inspect. They have been managed using BA 3993 and EM 5304 for our joints and the BA 9309 for deck hinges. Those documents have now been updated, leading to the CS466 and CS467. EM53 contained the provision for management of all joints, while BA 39 and parts of BD44 contain some provision for assessment. These have been merged, expanded, and have resulted in the CS466. BA 93 contained provision for both management and assessment, and they have been updated, resulting in the CS467. There are approximately 400 bridges with half joints and 100 bridges with deck hinges on the strategic road network managed by Highways England. The slide shows a close-out details of what a typical half joint look like, with upper and lower nibs forming a Z shapes. Half joints were most commonly used to facilitate construction, as suspended spans could be easily dropped into place after the side cantilever spans were built. Unfortunately, deterioration due to corrosion of the reinforcing bar triggered by water ingress into the joint and potentially leading to loss of structural capacity is difficult to detect. This slide shows a typical detail of a deck hinge, highlighting longitudinal and transverse views. The critical hidden deck elements of a deck hinge are the scissor bars and the dowel bar. As the vertical shear is transferred across the hinge through the bars, alone effectively, undetected deterioration of the bars could reduce dramatically the structural capacity of the bridge. In terms of risks and issues with this typology of bridges is access, which is difficult as often there are over live carriageways. Inspection and maintenance is difficult for this detailing because often require intrusive investigation. Defects are not often visible or obvious from the outside, vulnerable to waterproofing breakdown and water and de-icing salt ingress. Usually there's no alternative load path available, so they are susceptible to sudden collapse. The lack of robustness requires, therefore, careful management. Key changes in CS466 and CS467 when compared with the previous documents include changes to the management process, an increased flexibility given to the choices that can be made by the users of the documents in some aspects, including highlighting the importance of the structure condition, and some changes to the risk assessment process, the management plan, technical requirements, and guidance for structural assessment. For both documents, the management process is now clearly defined in a flow chart, as shown on the right-hand side of the slide. Triggers for initial review are defined, followed by a double layer of risk assessment that lead to either a new structural assessment for the bridge or directly to a management plan. The new documents include strategy for structures without signs of defects. And the main documents give the what is required to be done, but the how is achieved through guidance given in appendixes, giving flexibility to apply the advice in accordance to the circumstances. Also, in terms of inspections, there is a pragmatic approach where more emphasis is given on the condition and the need to confirm this. A recommendation for undertaking inspection specifically target at the half joint or deck hinge element to aid with the risk assessment are given that will need agreement and endorsement from the overseeing organization. In terms of the risk assessment process, as defined in the slides, the risk assessment process involves determining a primary risk rating based both on the detailing and the condition and the load capacity when available. Half joints in particular can have detailing of the reinforcing bar within them that would not comply with modern design principle and are therefore considered inherently more at risk. The primary risk rating can be further refined by using secondary risks such as the potential for disruption and the presence of vulnerable details, and there is also opportunity for sensitivity analysis based on the key parameters given. This slide shows a matrix, the main matrix for determining the primary risk rating of a half joint structure. The document now clearly spells out what the contents of a management plan would look like for 3 categories of structures: those assessed to have sufficient capacity, those that are theoretically substandard, and the new category of those assessed as having sufficient capacity but with concerns. The structure capacity may rely on assumptions such as condition of section properties that are considered to be extremely sensitive to change given the nature of this detailing. Therefore, the management plan for those 3 categories of structure following the risk assessment gives the potential measures that are considered appropriate for each type of outcome of the risk assessment. In terms of assessment, structural assessment of the half joints and deck hinges, the new document highlights the importance of the detailing of the reinforcement in evaluating the risk to the structural capacity. Detailing arrangement can be variable, but this, in both cases of half joint and deck hinges, can be critical to the structural capacity. One bar which is displaced or not present can dramatically change the ultimate load carrying capacity of the structure. Why were updates needed to the assessment part of the documents? In the CS466 for our joints, this is effectively a completely new document with extensive guidance on safe strat and time models that were not covered previously. The previous content in BD 4415 with regards to ULS assessment rules for our joint did not account for all the variety of potential detailing that can be encountered, and the lack of guidance often also resulted in unrealistically low resistance and departure from standard or methods of analysis and treatment of inadequate anchorage of rebars. In terms of the deck hinges, the content is now presented using a strat and tie approach, which is aligned with the CS466 and overall with the standard CS455 for assessment of concrete structures. And the part of BA 9309 dealing with assessment was written in a way that was a bit difficult to understand and could easily be misapplied to the confusing way it was presented. Now the writing is much more consistent. In terms of the key updates to the assessment provision, these are concerned with longitudinal loads, changes to requirement and advice on that, advice on short or inadequate reinforcement anchorage, the selection of analysis methodology, strat and tie analysis and assessment, and upper bound analysis. In particular, recommendations have been included with regards to taking into account the effects of longitudinal load onto the capacity of half joints and deck hinges. Effectively, both documents now include explicitly the taking into account of these in terms of evaluating whether the braking put net tension through the half joint or deck hinges in relation with the articulations, the condition of the bearings, and then there is better guidance on this key input to the assessment generally. In terms of short or inadequate reinforcement anchorage, recommendations are given that take into account as appropriate the affected short or inadequate anchorage of reinforcement, for example, due to the laminated concrete reducing the bond of the rebars, can have on the structural capacity of the element. In the slides, it's shown that diagonal bars in the half joint in green may have very short anchorage lengths. Can they be included in the assessment calculation or not? What if the concrete cover is missing or there is corrosion, and guidance is given in all of these aspects. Now, for the deck hinge, typically in the dowel bar, how much tension can be actually developed in the horizontal dowel bar, and the guidance is given of these aspects now. The new content in CS455, the DMRB document for assessment of concrete highway bridges and structures, that has a bond model for inadequate anchorage, is referenced in these documents, and for short or inadequate anchorage of reinforcement, effectively the new model permits through a reduction factor K COV to take into account this reduction in bond capacity due to deterioration. New content in CS466 and CS467 gives extensive guidance on how to model the resistance of the joints in these scenarios. In terms of selection of methodology of analysis for the structural assessment, there's been an improved and clarification with more guidance added. It is effectively, in both cases, a requirement to use a lower bound analysis like a strat and tie analysis. Lower bound analyses are on the safe side and can sometimes yield a low result. But when using the new guidance, refined strat and tie model arrangements, which are extensively discussed, can improve the resistance and give a more accurate assessment. Upper bound mechanism analysis have an inherent risk of giving potentially an unsafe result if the critical mechanism is not identified. However, they are very useful to understand to which degree the lower bound analysis may have been conservative, and can be useful in checking whether further revision of the strat and tie model is worthwhile or justifying a risk-based approach. The strat and tie analysis is now presented with the extensive guidance given, including the use of refined strat and tie models. Effectively, the principles of the strat and tie model is that of idealizing the part of the structure as a series of strat and ties, analyzing the forces in the strat and ties, then verifying the assessment stress limits are not exceeded and the strats and nodes fit within the section when drawn to scale, and then adjusting or optimizing the model if required. Strat and tie approach to shear resistance is given in CS455 and it's referenced in the document, but CS466 and CS467 give additional guidance for half joint and deck hinges on how to build and verify adequate strat and tie. The guidance given will be of very much use for the assessors to building up strat and tie models compared to the previous versions of the document. In terms of half joint, guidance is now included on advanced strat and tie models where plastic redistribution of the force is assumed. For the strat and tie analysis of half joints where some reinforcement is expected to yield before the ultimate state is reached, and when this reinforcement has sufficient anchorage, effective plastic redistribution may be improved to improve the assessed capacity. The methods for modeling the effects of plastic redistribution in strat and tie analysis can include using statically indeterminate strat and tie models to control tie forces, using the superposition of complementary strat and tie systems, using strat and tie models with wider strats, or strats that fan out radially, and larger nodes in order to increase the number of reinforcement bars assumed to contribute simultaneously to a tie at yield. Using this approach, it has been shown to significantly improve the result of strat and tie assessment in some cases, for example, even at the level of bringing the capacity from a theoretical zero traffic to 40 ton ALL. In terms of, again, half joints, a new appendix to the CS466, Appendix E, clarifies and gives worked example on the methods for using plastic redistribution. Guidance is also given on how to model the presence of post-tensioning, detailing of horizontal nib reinforcement, bent up diagonal reinforcement, corrosion, spalling, longitudinal reinforcement not being enclosed by links, loads applied through discrete bearings, and transition from solid half joints to discrete beam webs. As far as the deck hinges are concerned, the assessment process previously contained in BA 93 has been rationalized and presented in a form of a strat and tie model in full compliance with their overall approach. The slides show how the capacity of the deck hinge is first assessed by using a strat and tie model that does not rely on the dowel bar, and with additional contribution then given from the concrete in compression and or the dowel bar in tensions. The approach is effectively equivalent to what was a process in BA93, but it's more clear and logically expressed in the form of Stratton-Tye models. In terms of the assessment of deck hinges, there's guidance given now on how to allow for reduction in section of the hinge bar, including when fatigue analysis is performed. For example, to take into account allowance for faulty construction with reduced hinge throat dimension in model, allowance for deterioration, corrosion of bars, and reduced hinge throat dimensions in the model. A fatigue assessment is required for deck hinges, as experience has proven that fatigue of the hinge bars due to their localized bending may be critical. Guidance is now given on a simplified method for fatigue assessment with the specific details to be agreed at the level of the AAP, approval in principle. In terms of upper bound analysis for half joints, CS466 now describes how to do upper bound mechanism analysis to supplement, not replace, Stratton-Tye analysis. This energy balance method has not been presented in the DMRB before, but it was conceptually subject of a number of departures from standard. Its inclusion is based on new research on how to model the energy dissipation in concrete in shear-off situations. CS466 also gives new advice on reduced bond strengths to account for splitting during the development of a failure mechanism. To conclude, effectively, in terms of impacts and benefits, the new documents contain a consistent approach with clearer requirement and updated guidance to proactively risk assess, prioritize, treat and manage vulnerable structures such as half joints and deck hinges. Remove the need for departures from standard by incorporating requirements and guidance from previous departures and recent research. Improve safety by promoting more accurate assessments and more robust risk-based decisions. And then lead to reduced cost due to less intervention and reduced network disruption through less conservative assessment. In terms of communicating the changes, we are communicating the key changes with DMRB with bulletins available to view on the Innovation Hub website. And here is the link. We prepared several webinar tutorials such as this one to explain the key changes to individual documents. We've made several presentations to external organizations to explain the update to the DMRB. Items related to DMRB are often in technical publications. New DMRB documents can be found in the Standards for Highway website. Withdrawn or superseded documents from 2001 can be found in the archive section. For older documents, our standard inquiry address can be emailed. New documents are to be implemented as soon as they are published as set out in GG 101, with exception being possibly to propose should implementation result in significant time or delay or cost. Welcome feedback on questions, and this can be posted using the email address shown. Thank you for listening. Actually, acknowledgements, which I forgot. This webinar was prepared with the assistance of Dr. John Shave, Eleanor McDade, and Guan Xing Lo of WSP, who have been co-authors in the drafting of CS466 and CS467, and whose contribution is gratefully acknowledged.